Guys, all right, so what we're gonna do is we're gonna work with graphing just sine function. And there's gonna be some things that you see on the left side. We're gonna have the amplitude, the frequency, the vertical shift, and the period. And then we're all working in degrees currently. So we're gonna break this down piece by piece, and hopefully my technology will work and we'll just roll right through it. All right, so when we come over here and you see that it's y equals sine of x, remember the general form is y equal to our amplitude sine of, and then we have our b, which is our frequency, plus c, which is our vertical shift. So a is the amplitude. Our b in this case is going to be our frequency. And then C is our vertical shift. Now, the one other thing that you see on here is our period. Our period, because we're working in degrees, is 360 divided by our frequency, which is B. So let's go ahead and use all this information using this as a general guide here. And we're going to go through and find these four pieces. And then we're going to use those four pieces to help us graph. So number one, we have y equal to sine of x. And you can clearly see the number out in front of sine. It's not that it's nothing there. There's a 1 there. We just don't always write it. So in this case, our amplitude is 1. Our frequency, again, just like the amplitude, you don't physically see a number out in front, in this case in front of our x. And so when that is not visibly seen, we have a 1 out in front, so our frequency is also 1. Our vertical shift, there really isn't anything out here. That doesn't mean that there's a 1 like the amplitude and frequency. It actually means there's a plus 0. It hasn't moved anywhere. So our vertical shift, we're just going to write is 0. And then our period, I'm going to write out what we would write every time. It's 360 divided by 1. Remember that 1 comes from our frequency. So our period is 360. Remember what the period means is that it's going to take 360 degrees in this case for the sine function to start cycling again, to start repeating. So now we're going to go through and start graphing this. And so our sine function always starts on our midline. And so the first thing I want to do is figure out our first step. What I like to do is I like to say vertical shift. So step 1 is my vertical shift. Doesn't move anywhere. In this case, the answer is no. So I'm going to create my midline right on the x-axis because it does not move at all. The next thing, once I have that, then I start thinking what function it is. So it's my sine function. And so I know my sine function starts and ends on the midline. And so, oh, sorry, I did not mean to do that. I cannot go back and undo, I don't think. Let me see here. Nope. Okay, so we're just going to roll with it. So I'll just use this color then. So here we have at 0, it's going to end at 360. And then also for our sine function, it starts and ends on the midline, and also half of the graph in the middle of the graph, or I should say in the middle of the cycle, it also is on the midline. So we go to half of 360, which is 180. Now next, we use the amplitude. And the amplitude tells us how far away from the midline the maximum minimums are. So our hills and our valleys. So between your midline points, you have either a hill or a valley. And because our function is positive, you can see right here, this function is positive. This is just a positive 1. We are going to use that to graph our amplitude 1 above here halfway through our first two midline points, and then below down 1 here. Now, if that sine function would have been negative, instead of graphing the point above the midline, the first one, we would have graphed it down here, down, because it would have a negative direction. But because that's not the case, we start above. And you'll see it'll come up here shortly. And so because it says just to graph one full period, we're just going to connect our points here. And then there's our function. All right, so let's see if I can scroll this down. All right, so let's break this up again. So amplitude. Amplitude is the number out in front of sine. In this case, it's 1. And I should have said this before, but amplitude is always positive. So remember, the amplitude is the distance away from the midline. And so distance is always positive when we're talking here. And then our frequency is the number out in front of the x. In this case, it is 1. And our vertical shift is that +2 that you see on the outside. So vertical shift is +2. Our period again is 360 divided by our frequency, which is 360. I know you're probably thinking, why do we have to write 360 divided by 1? It's a great habit. That way muscle memory kicks in when that number does change. And so now we go to graphing. Remember, the first thing we did last time is I like to move my vertical shift so I can move my midline. So I go up 2 units from the x-axis. And so I go right up here. And then from there, then I'm able to plot my beginning and my end. And we know that because the period's 360, I plot 1 on the y-axis and I plot at 360. Notice how I'm graphing on my midline now, not on my old midline of the x-axis. We've shifted it up. So the whole graph's going to move up 2 units. And so I also have my middle point here, which is 180. And then again, the number out in front of sine is +1, so I'm going to start going up from my first point. So I'm going to go up halfway to my hill, and then between my other 2 midline points, I'll go down to my valley, and then I can connect and roll. And you can see from these two, you can see that what I've done is I've taken this exact thing. It's the same thing here, but it's just shifted up 2 units, and that's because of my vertical shift. Okay, so now let's move on to our next piece here. So in this case, our amplitude is 2. The 2's out in front. Remember, it's always positive. Wouldn't matter if that was a -2 or not out in front of sine. Our amplitude would still be +2. Our frequency is the number out in front of x. In this case, it's 1. Go back to my color coding system. And my vertical shift is 0. Our period is still 360 divided by 1, right? Which is 360. And so because our vertical shift is 0, our midline does not move. It just stays on the x-axis. And so I know that I'm going to start and end. Start at 0, end at 360 because my period is 360. Again, we know that in the middle of those 2 points, which is at 180, that's also a midline point. And then now here's where it changes a little bit. Our amplitude is 2. Remember, our amplitude is the distance away from the midline that our maximum and minimums lie, or our hill and our valley. So between 0 and 180, which is at 90, instead of just going up 1 from the midline, we're going to go up 2. And then again, instead of going just down 1 from 270, we're going to go down 2. And then you can graph. And I'm going to go ahead and put, if our amplitude was 1, like our very first one that we did, you don't have to graph this, but our very first one we did, it just was like this. And you can see all it did was it got taller. It stretched by an amplitude of 2. Our max and min went from 1 above the midline or 1 below to 2 above and or 2 below. You can see each one we're working with one other thing. So one number is changing each time. First, the vertical shift changed, then the amplitude changed, and now you should be able to see the frequency is going to change. So with the frequency changing, you're going to see the amplitude is still 1 out in front. The frequency is now 2, it's out in front of the x. And then our vertical shift is neutral. It doesn't move. So our period, again, is 360 divided by our frequency, which in this case is 180. So what it's going to do is it's going to shrink in a perspective. It's going to shrink and collapse from left to right. It's going to like a slinky. It's going to collapse it a little bit. So we're going to continue with our vertical shift, which is 0. So we're going to go 0. And then remember, our period now is 180. So we're going to end at 180. Our other midpoint, or midline point, is halfway between, so it's at 90. And so you can see that our original one, it's shrunk down. It's collapsed. And then between 0 and 90 is when our amplitude, or in this case, will be our hill because it's positive. We're going to go up 1. And then between 90 and 180, we're going to go down 1. And you're just estimating about halfway between those based off the graph that we're given. And again, I'll plot our original one so you can see how this has changed. That was our original function. You can see it's collapsed. It's shrunk down. Again, I use the term like a slinky. Okay. So the next thing I want to do is I want to show you what happens with a negative sine value. So a negative sine value, what it does is it just changes the original direction from our starting point. It also, another word to say it, is it reflects across the midline. That's another way of saying it. And that's something you could be used to when we did quadratics with x squared. If you have a negative x squared, it flips your parabola upside down. When you have cubics, it would change your end behaviors. It would flip them. So it's the same thing here. It just changes the direction that it originally goes. So we're going to go ahead and fill this out. Our amplitude is still positive 1. Remember, our amplitude is always positive. The negative out front tells us the direction and or the reflection. The frequency is 2. The vertical shift is 0. And then our period is 360 divided by 2, which is 180. So we go to our graphing here. Our vertical shift goes nowhere, so we're just going to, again, put it onto the x-axis. Our period goes from 0 to 180. It takes 180 degrees for this thing to cycle through again. So we go 0 to 180, halfway to 90. And then now this is where it changes a little bit. Our amplitude's still 1, but instead of going between 0 and 180 and going up 1, we're gonna go down 1 because of this negative right here. That negative tells us to start our direction going the opposite way. We're reflecting across the midline. So then between 90 and 180, we're going to go up 1. And so we dealt with two things. We dealt with our frequency being 2, where it shortens our period, and then also the negative, it flips it, reflects it, and starts the opposite direction, however you want to say it, to our graph. All right, so number 6, I kind of want to show number 5 and 6. If you look at number 5 and number 4, the frequency was 2. And so what it did is it shrunk the graph from left to right. It squeezed it. But notice how in number 6, our frequency is a fraction. It's something between 0 and 1. When your number's between 0 and 1, you would think that it reduces the graph. But in actuality, what it does is it stretches the graph from left to right. It's going to expand it and make it longer to cycle through. So now I'm going to move this up so we can see it here. And so we're going to go through it. Our amplitude is still 1 here. Our frequency now is 1/2. And then our vertical shift is plus 0. Now, anytime I have a fraction and you think, well, we have to take, how do we find the period? We take the period, which is 360 in our case, and divide it by 1/2. Well, if I write 360 divided by 1/2, it just is unsettling. And so what I'd rather do is, when I have a fraction as a frequency, I would rather write 360 divided by whatever my frequency is. Because I know that if I want to divide, if I have a number and I divide by a number, I can take the original number, in this case 360, and change that division to multiplication by multiplying by the reciprocal. So we're going to go 360 times 2. Because if you flip, the reciprocal of 1/2 is 2 over 1. And so now my period is 720. Now maybe you can see why I'm only having you here graph one period. Because now we had a lot of wasted space, but in this case we're going to go all the way to 720. So our vertical shift is 0. We haven't moved anywhere. And then we have sine, so we're going to start at 0. And we're going to go all the way to 720. So way out here. And then remember, we have another point halfway between the period, the cycle. In this case, it's going to be 360. That's on the midline. And then between 0 and 360 is going to be a hill because our sine function is positive. Our amplitude is 1, so we're going to go up from 180, up 1. And then between 360 and 720, we have 540. And from there, we're going to go down 1 because our amplitude is 1. So you can see that blue graph is what y equals sine of 1/2 x looks like. Now, if we go back to what's y equal to sine of x, y equal to sine of x is a little different. It's basically shorter. Right? And if we go even further, and see if I get a different pen color here. If I want to graph y equal to sine of 2x, you can see that what it does is it actually shortens it even more. So our blue graph is where our frequency is between 0 and 1, so see how it's stretched out. The red graph is where our frequency is just 1, so that's our parent function. And then the orange graph is when our number is bigger than 1. And so what it does is it shrinks it. All right, so 7. So what you have to be careful of when you get to 7 and 8 is that there's multiple things happening. But what I like to do is if you think you could do it, go ahead and pause it, of course, and then come back because I'm going to do it here. I'm going to work this with you, and I'll explain it too. So if you want to pause, go for it. So we're going to go ahead and fill out all the pieces like we've done before. The amplitude is what's out in front of sine, so it's 3. Our frequency is what's in front of the x value, so it's 1. Vertical shift is -1. Or some people like to write down 1, same thing. Period is 360 divided by our frequency, which is 1, which gives us 360. Now we get to graph. Remember, first thing we graph, vertical shift. We're moving it down 1, so we're going to move our midline down 1. Then we look at what our period is. Our period is 360. And since it's 360, we start on the y-axis. We go all the way to 360. Halfway between is 180. Between 0 and 180, we now use our amplitude. Our sine function is positive, so we're going to go up between 0 and 180. And how far we're going to go up? We're going to go up 3 units from the midline. So in this case, it's 1, 2, 3 units from the midline, right? 1, 2, 3. We discredit this x-axis anymore. We've moved away from it. So we're going to go up 1, 2, 3. And then between 180 and 360, we're going to go down 3. And so you can see that we've moved our whole graph down, and we've made it stretch out taller. Okay, so I'm going to do 8, same thing as I did 7. I hope that if you paused it and tried 7, you felt like you got it. Now with 8, same thing. If you feel like you want to try it on your own, you go for it. And then I'm gonna work this, and then when you come back, you can push play and see me work through it. So go ahead and pause this now if you'd like to do it on your own. All right, so Whether you've paused it or you just continue to follow along, we're going to work through the whole thing again. So amplitude in this case is 1/2. Our frequency is 3. It's the number out in front of the x. Vertical shift is +1. And then our period, again, is 360 divided by our frequency, which is 3, which gives us 120 degrees. So we're really going off kilter here, and when we look at our graph based off of what it's given us. So we're gonna do some estimating here. All right, so our vertical shift. Let's take care of our vertical shift first. We're going to move everything up 1. And now we're going to use our period. Our period only goes to 120 degrees. So we're going to go 0 and estimate where 120 is. And so I'm going to say it's somewhere right in here. Just estimation. And then halfway between is 60. And we're going to say 60 is right in here somewhere. So there's our midline points. Our beginning, our end, and our middle. Now we use our amplitude. And say that our amplitude is, first off, our sine function is positive, so we're going to start going up from 0 to the middle point. In this case, it's 60. And we're going to go up, and we're going to go up by 1/2. So we're going to use another estimation. A whole full unit would be up here, but we don't want that here. We only want 1/2 of that. So we're going to go up to here. And then we're going to go down here. And then we connect it. All right, so hopefully this helps with knowing graphing sine. And hopefully you don't have any questions. If you do, feel free to email me.